Hi, welcome back to another episode of FRC Robotics 101. I'm Tang, and today I'm bringing you a continuation on the topic of CAD. As we said in the last episode, this one is going to be about sketching, the process that you would need to get all of the numbers for your model of the whole robot, for your prototype, and for manufacturing later on. Because this is going to be a long episode, let's jump right into sketching.
So let's start with step 1. Normally, we'll start by creating some infinite lines horizontally, which will represent the surface that your robot will stand on, which is the floor. You need a few of these lines to represent the different views. You can get one to be the view from the side, one to be the view from the front, and one to just zone out different stuff. You can get the view from top down, you can zone out the different mechanisms that you might not include in your robot. That is for basically all of your backup plans and the additional informations. Then you can start adding in different components of the field. So in this case, I'll start by adding in the tower. So you would need to add in all the numbers included with each game piece. So in this situation, with tower, I would need to include the size of the hole, the height of the tower, the size of the inner hole, the size and the location of the lower hole, and all of those numbers. One thing to keep in mind is that normally competition includes both the metric and imperial numbers for all of their calculations, but you would normally use the imperial if your competition is in the US, because the metric number is usually rounded up, and you don't want to use rounded up numbers for all of your calculations, because in the long run that will lead to a lot of errors. Trust me. So I'll get you a more detailed example of just how to represent the game field pieces on your sketch. So here I will sketch out the control panel, basically the disk for the FRC 2020 game. So I can just start out by drawing the view of it from the side, because that's normally what you need to do all of your calculations. So just draw a rectangle to represent the side of the table, and you also represent the disk with another rectangle. Then you start adding in all of the numbers. As you can see here, I start by adding in the numbers related to the disk, because actually that is the main part. The table doesn't really matter except when you specifically include some kind of weird strategy with it. But as you can see, it kind of flipped, so after a while I just scratched that idea and just add in all of the numbers related to the table. Sometimes when you add in these numbers, it might turn out weird like that, but don't worry. If something's wrong, just cut out one or two numbers, add in all of the other ones. It will turn out fine when you add in all of the numbers. Don't worry. Okay, after you get all of the numbers related with the field in, you would want to start drawing out your mechanisms and entering in numbers that you cannot change for your mechanisms. Numbers like basically the size of the wheel, the size of the game piece that you're interacting with, all of those things. Another thing that you would need to define here is basically your goal. For example, as we're drawing a shooter mechanism here, I'm drawing out the trajectory that I want, and basically by drawing that out, I'm drawing out the space between which my robot can actually score the goal. I'm representing the trajectory of the closest point and the furthest point with two lines, as you can see here. Because we're using a two-wheel shooter, I expect it to fly up pretty fast, That's why I'm just using a straight line to represent the trajectory. After that, I start sketching out the actual mechanisms. I start by just drawing out some lines to represent the general shape. Then I draw in the game piece, the ball, and also I drew a rectangle to represent the wheel. This mechanism is, as I said before, going to be a simple two-wheel shooter, but you can actually change the angle of it by changing the distance between a point on the actual robot and a specific point on the shooter by unscrewing a long big screw, which will be connected to a very slow motor. Really, what I want to figure out with the sketch is the actual numbers I need for the screw, because if the screw is too short and you only needed to travel, let's say like 2 centimeters for it to change the angle between scoring from 3 meter and scoring from 7 meter, it would not be good because the error is going to be too big. I want it to be, but I don't want it to be too short, so the error will be very big. I want something in between, somewhere that maybe I can change like 20 degrees with around like 7 to 10 centimeters. I think that would be fair. So I just start entering in all the numbers, drawing out the general shape of it, and I'm keeping the distance between the specific point on the robot and the specific point on the shooter as a driven dimension, so that when I change all the other numbers, that will be changed. So in step 3, after you have drew out your mechanisms, drew out the numbers that you actually can't change, you start tweaking your numbers. This can take you from very short, like maybe only 20 minutes, to taking a long time. Trust me, in this case I only changed like 2 numbers, one of which I can't really change much because the size of a robot actually kind of restrict it a bit. I'm just changing basically the point on the robot that the screw is going to be originating from. So I'm just changing that point and see how the other numbers on the screw are going to be. Mostly just the distance that the screw need to unscrew to change the angle. Basically, from what you see here, I got it within like 2 tries, but for some mechanisms that are more complicated, for example, if you're using things like a turret with a flywheel, you need to change a lot of numbers. You need to draw out totally different things. For things like climbing mechanisms, you would need to draw out and change a whole lot of numbers, but for this case you just need to tweak the numbers a whole lot. After a few tries, I got the numbers that I want. But normally you would not just stop with one number. You need a whole table full of numbers so that you can do your actual prototyping. To get you another example of how to actually sketch, I will run through footage of me just sketching out this same shooter mechanism from the top down to get in some other numbers. So what I want to figure out here is basically the distance between the wheel so that the ball can shoot out with, well, optimal strength. So the rule of thumb that I was taught is basically to get the distance between the wheel to be about like 3/3 of the diameter of the ball. But because for the FRC 2020 game, the actual ball is pretty soft, you can deform it a whole lot. So I actually went with a bit less than 3/4. The ball is 7 inches in diameter. The distance between the wheel is going to be 5 inches. But the thing is, because this sketch is only for the prototype, or maybe the first time that you're manufacturing your robot, you want it to be able to change a bit. You don't want to just basically have to manufacture a whole new part just to change like one single number. So that's why the position of the wheel is not going to be static. Basically, I'm drawing out some slots so that they can move around, and that also needs some sketching to do. So basically, I'm drawing out some. Can you cut the previous sentence? So basically, I'm drawing out some slots so that the motors and the wheel can slide in and out a bit. So, and that also needs a whole lot of sketching. So as you can see here, I just draw the basic numbers like the thickness of the aluminum, the wheels that I'm going to use, the size of the ball. Then I can start to figure out all the other numbers. Basically, the motors is going to be on aluminum piece, a small piece only, and that piece will slide along a frame that is going to be the actual shooter. Okay, as you can see here, when drawing out the slots, there are a few things that you need to consider. First, you would need to consider the size of the small piece of aluminum so that it can fit all of the slots without deforming too much. Your motor is going to spin a whole lot, it's going to work for a long time. There's a chance that it will deform the metal, and you don't want that to happen, so you want all of the walls to be a bit thick. Normally, I don't want any part of the aluminum to be less than 3 millimeter, and that's basically what I'm doing here. I'm drawing out all of the slots I need, and then I make it so that they are spaced 3 millimeters away from the walls. So what we need here is basically a central slot, the biggest one, for the actual axle of the motor. Then you need 2 on the sides, or how many ever on the sides, to attach your motor to the actual plate. And then you need 4 or so more to basically make the slots for the plate to slide on your actual frame. As you can see here, I have a big one in the middle, 2 on the sides, and I'm just now drawing 1 in the corner so that I can mirror it to all 4 corners. I need to change the size of the aluminum piece a bit so that it can fit everything without breaking too much. Also, when you're drawing out this, you should also draw out basically the slot on the actual frame itself so everything can slide around.
So that's all I have for the basic of CADing. Particularly about sketching. I know that this whole episode about sketching might seem excessive, but I'm sure that this will prove helpful for you later on. That's it for this episode. Thank you for watching and listening.